Hello, I'm Bretton, one of our MCAT tutors here at Inspira Advantage, where we help students get accepted into med school and other professional programs. Today, we're exploring how the nervous and endocrine systems work together to coordinate other body systems. This is going to be a big doozy of a video, but very important for the MCAT. These two systems act as the body's control centers, regulating and integrating the functions of all other systems. Let's start by reviewing the key differences between these systems. First is speed. The nervous system acts quickly, milliseconds, while the endocrine system acts more slowly, seconds to days. Duration. Nervous system effects are typically short-lived, while endocrine effects can last much longer, like puberty. Specifically and specificity. Nervous systems target specific organs or tissues, while hormones can affect multiple targets throughout the body. After all, nervous systems talking to 1 to 30 things, whereas hormones are just getting dumped into the bloodstream. Anything with a receptor will hear its call. Now, let's look at how these systems coordinate other body systems. In the cardiovascular system, nervous system sympathetic stimulation increases heart rate and blood pressure, whereas parasympathetic does the opposite. Endocrine functions, such as epinephrine, increase heart rate and blood pressure. Atrial natriuretic peptide decreases blood pressure. In the respiratory system, the nervous system's medulla oblongata controls breathing rate. Sympathetic system dilates bronchioles. The endocrine side of things, epinephrine dilates bronchioles. Cortisol enhances the effect of epinephrine, ultimately causing more oxygen to get into the body. The digestive system, the nervous system's parasympathetic stimulation increases digestion, while sympathetic decreases it. The endocrine system's gastrin stimulates gastric acid secretion. Cholecystokinin stimulates pancreatic enzyme release. So how might the body respond to a sudden drop in blood pressure? Well, the nervous system would trigger a quick sympathetic response to activate heart rate and constrict blood vessels. The endocrine system would release epinephrine and activate the renin-angiotensin aldosterone system for long-term blood regulation. Let's continue on with some other systems, such as the immune system. Nervous system sympathetic activation generally suppresses immune functions, whereas endocrine's cortisol will suppress inflammation, growth hormone, and prolactin enhance immune function. There's a lot of crazy effects on the reproductive system. The nervous system's autonomic nervous system controls sexual arousal and orgasm. The endocrine system's hypothalamic pituitary gonadal axis regulates the entire reproductive cycle. In the musculoskeletal system, the somatic nervous system controls voluntary muscle movement, whereas the endocrine's growth hormone and sex hormones influence muscle and bone growth, while parathyroid hormone regulates calcium levels, important for signaling and bones. The coordination between these systems is often complex. For example, the stress response involves both systems. The nervous system immediate fight or flight response via sympathetic activation, and the endocrine system's activation of the HPA axis, leading to cortisol release for long-term stress and adaptation. The coordination between this dual response allows for both immediate action and sustained adaptation to stressors. Here's another question. How might chronic stress affect the immune system? Answer from both a nervous and endocrine point of view. While chronic stress will lead to prolonged elevation of cortisol via the HPA axis, this can suppress immune function, potentially increasing susceptibility to infections. And this chronic activation of the sympathetic nervous system could also lead to long-term fatigue. Now let's take a look at glucose regulation. The sympathetic system will stimulate pancreatic alpha cells to release glucagon, whereas for the endocrine system, insulin and glucagon directly regulate blood glucose levels. This one's kind of wishy-washy because glucagon is acting as an endocrine signal. For growth and development, we've got the hypothalamus releasing growth hormone, GnRH, and the pituitary will release growth hormone, stimulating IGF-1 production in the liver. When it comes to water balance, the nervous system's hypothalamus is sensing blood osmolarity, which can then have endocrine functions by the posterior pituitary releasing ADH to regulate water reabsorption in the kidneys. The integration of these systems allows for fine-tuned control of body functions. For instance, during exercise, the nervous system increases heart rate, breathing rate, and blood flow to muscles, and the endocrine system is releasing cortisol and growth hormone to mobilize energy sources. Now, this is not the be-all, end-all of these systems. I just want to provide a big overview so you can see the most common questions the MCAT is going to ask on the difference between nervous and endocrine systems in these tissue systems. Understanding this coordination is absolutely crucial for grasping how the body maintains homeostasis and responds to various stimuli and challenges. We will do deep dives into all of these systems. So don't worry if you've got more questions that are not yet answered, but this alone will really help you get a lot more questions right on the biochem sections of the MCAT. Thank you so much for watching our video on the coordination of body systems through nervous and endocrine systems, and I will see you next time.